I'm not going to show you how to divide yet because that'll give you nightmares. We're going to go multiplication first for today and then division maybe later on this week. If I feel you're ready for it, because it's going to give you nightmares. I'm going to write example 1. How about x plus 3 times 2x minus 4? So notice I have two binomials now. We're going to multiply these puppies. We're not adding them, we're not subtracting them, we're multiplying them. Notice how they're right next to each other, the parentheses, right, Esquivel? Phone's away right now? We're digging right into our notes now. I'll play this day in history later. I know students like Munoz, who's had me for Math 2, should recognize this. What do I do, Munoz? Right. Loops. In other words, Sicaros. When you say go into, what do you mean? Distribute by multiplication, right? In other words, you guys are both right. I'll say it a different way. Every term here, I'll multiply by every term here. Let me say that again. I have two terms, the x and the 3. I'll multiply both those by the 2x and the minus 4. And make sure everything here is multiplied by everything over here. That's one way to see it. In other words, x times this, x times negative 4. 3 times this, 3 times negative 4. And I'm going to have this nasty long polynomial that I'll have to simplify. So x times 2x. Right, so let's see. Let's multiply the coefficients. The 1 times a 2 becomes a 2. X times x, you add the exponents, it becomes x to the second power, notice. So 1x times 2x becomes 2x to the second power. 1x times negative 4. So 1 times negative 4 becomes a negative 4 attached to the x. Rockin' and rollin'. 3 times a 2x, that becomes a 6x. And then 3 times a negative 4, that becomes a negative 12, right? Or plus negative 12 means the same thing. We have this nasty long polynomial expression. It's bad manners to leave it that way. We have to simplify it, in other words. There's something we can simplify here. The x's on. Negative 4x's and 6x's I can combine. Those are like terms. I'll write my final answer in black. 2x squared then. Negative 4 plus 6 is positive 2x plus a negative 12. We end up having a trinomial as our final expression. Easy. Easy lesson today. All right, let's step it up a notch. Let's step it up a notch. Example 2. 9 minus 9y rather. 9y minus 2 squared. Nine y minus 2 squared. Now the benchmark that's coming up in Pomona, by the way, we scored the highest last year in the benchmarks, our Math 2 class. We beat Diamond Ranch, Pomona, Ganesha, Gary, all this. Thank you, extra stats for you. Our class, the Math 2 class, scored the highest. I'm confident that what I've taught you thus far, you guys are in a position to score the highest in Math 3. Believe it or not. It happens often. But on that benchmark that's coming up, what's something that will happen in a problem like this that students that'll cause students to get it wrong? In other words, what's a temptation? Kind of like if a hook to catch a fish and they catch it and they bite the bait and then another dead. What's the bait here that'll cause students to die on this question? Okay, let's see Ekasan first and you. Go ahead. One more time. what would they do? What would students do with that exponent? That's where the problem's at. You're right, but can you tell me what would cause them to die? That would be completely wrong, but they're like, oh man, I gotta do that. There's something I gotta do. Can you think? Hold up, I got you. Somehow to help them out. What would they do? What would cause them to die here? But they'll actually bite the bait and do it. Munoz. What do you mean by do the exponent? So what would they? How would they handle the exponent? What would they do? What would they write down? Tell me what they would write down. Can you think? Phone's away. Thank you. Extra stamp. If someone could tell me what would students do that's wrong right here. A lot of students do this too. Students will see this exponent kind of like this. Like if you have this, you distribute the two, right? That's good. But they'll think that you could do the same thing with an exponent.
Oh.
You get what I'm saying? In other words, students will think, hey, oh, that exponent, I can just rewrite everything like this: 9y squared minus 2 squared. No, 1,000 times no. No, that doesn't mean that. Okay? What it does mean is, well, who thinks they can tell me what it really means? Let's go, Garcia. Go. By itself. This means this binomial times itself means this: 9y minus 2 times itself. Very good, Garcia. That's what that means. Go write that down. Anything to the second power means that times itself. So the whole dang binomial, I'm going to multiply it by itself. Or I'm going to color code this puppy. We got a binomial times a binomial. Let's do it. 9y times 9y, and then the 9y times the negative 2. Let me use green now. The negative 2 times the 9y, and the negative 2 times the negative 2. Let's see what happens. There we go. 9y times 9y is going to be 81y to the what power? Thank you. 9y times a negative 2 is going to be a negative 18y. Rocking and rolling. Right, Rios? And then I got a negative 2 times a 9y is another negative 18y. Put that one in green. Negative 2 times negative 2 is positive 4. Nice. Like terms time. Y squares, there's none to combine, so that's going to be in my final expression, 81y squared. And I got a negative 18y and negative 18y. Those are definitely like terms. Negative 18 minus 18. Positive or negative? Nice, because this is a plus negative here. So I got a negative 36y. Excellent. So like terms are like terms. I got the plus 4. We're rocking and rolling. We've got a trinomial again. Cool. Two more examples. Shift into third gear now. Third gear. Example 3. Third gear says 3x to the third. Here we go. 3x to the third. Excuse me. Minus 9x plus 7. I got a trinomial now. Dang. X squared minus 2x plus 1. I got a trinomial times a trinomial now. This is third gear. This is math 3, big league stuff now. Binomial times binomial that we've been doing, you should have saw that in math 2. You should have, if not, no big deal. So let me color code this. 3x to the third, I'll multiply by the x squared, I'll multiply by the negative 2x, I'll multiply by the 1. The negative 9x, I'll multiply by the x squared, by the negative 2x, and the 1. And then the 7, I'll multiply by the x squared, by the negative 2x, and by the 1. So we're going to distribute 3 times. It's going to be crazy. Remember this, Munoz? Some of you should remember this from math 2. So it should be an easy lesson today, nothing crazy. All right, I'll go in red first. Munoz, 3x squared times x squared, give it to me. 3x cubed times x squared. Oh, shoot. Sorry, Rio, supper. 3x cubed times x squared. What would that become? Hold on.
3x to the 5th?
Hold on. What do you think, Rio?
3x
To the?
to the square.
Let's add those puppies. Add the exponents.
5.
Nice. 3x to the 5th.
That's it.
Well, that's for these two. Now look at, now I'm gonna distribute the 3x to the third to the second term. Look at 3x to the third times a negative 2x. What would that become, Zavala? First coefficient times coefficient of the numbers in front, like the 3 times the negative 2, that becomes a negative 6, yeah?
Negative 6 to the third?
X to the close. Fourth, huh? Because this is a 1 power.
Yeah.
There's nothing there as a first power. Sanchez. 3x to the third times 1. What do you think? We'll just multiply the 3 times the 1, which is 3, and just attach x to the third. So 3x to the third times 1 is 3x to the third. Let's go, and now I'm going to use green now for the second distribution. So now I'm multiplying the negative 9x squared times everything. Negative 9 times a 1 is a negative 9. X to the third on 1 plus 2 is 3. Negative 9 times negative 2 is positive 18. X to the second. I trust you guys are with me here. And then I got a negative 9x squared times 1 is a negative 9x squared. Or negative 9x rather, not x squared. Run out of room here. Cram the rest of the stuff in blue. Dogger blue, you guys see them win yesterday? 7 times 1 is 7x squared. 7 times negative 2x is a negative 14x. And then the 7 times the 1 is a 7. We're ready to rock and roll now. I have color coded it. All 3 distributions. That's a nasty, nasty expression. It's making me sick just looking at it. Look at that thing. It's a monster. That is a monster. Okay. Like terms? 3x to the 5th I can't combine with anything. There's no other x to the 5th terms. So that comes to my final expression. I like to cross them out when I know I'm done with them so it alleviates confusion. X to the 4th, is there any other x to the 4th? There's not. So that comes to my final expression. There's definitely x to the thirds. This one and this one. I can combine them. 3 minus 9, help. Negative 6, x to the what, x on? Nice. It keeps this third power. Okay, you don't add the exponents when you're subtracting or adding. You only add them if you're multiplying. I like to cross those puppies out. X squared, nice. I can combine those two. 18 and 7, 9, 10, 11, 12, 13, 14, 15. No. 19, 20, 21, 22, 23, 24, 25. X to the second. And I got the x's and x's. Negative 9 minus 14. How many? So bad on mental math. X, negative 23x plus 7. Look at this beastly polynomial. Nasty. Last example. Questions? On this last example, I want you to go and draw a rectangle, if you would. Right, let's get a rectangle going here. Looks like a square. I need a rectangle. We get a rectangle going. Here we are. So an example 4. I'm going to draw a rectangle like you see here. Here's example 4. All right, find the area. Find the area. And for the length, it's going to be 2x plus 3. The width will be x plus 2. Just find the area. Does anybody remember how to find the area of a rectangle from like math 1 stuff? Hit it. Multiply those things. That's how you do it. You multiply those things. What's the area form of those, Staccatos? Area is equal to what for a rectangle? Remember? Thank you. Length times width. Length times width. Length is always the longer side. Length is 2x plus 3 units. Width is x plus 2 units. Just multiply those puppies, and you got your area. You see a lot of these on benchmarks. They always throw a polynomial at you, or a rectangle of some sort, and ask you to find the area, or the perimeter. So the area then is length. Length is always your longer side. That's 2x plus 3. The width is x plus 2. All right, let's rock and roll. Let's rock and roll. 2x times x, 2x times 2, 3 times x, 3 times 2, and we're done, right? That's it. Here we go. Area then is 2x times x is 2x squared. 2x times 2 is 4x. Nice. 3 times x is 3x. 3 times 2 is 6. And we got our area. Let's just simplify the expression. So the area then of this rectangle, like terms of my 4x and 3x. That makes 7x, huh? So 2x squared plus 7x plus 6 There's your area of the rectangle. A stands for area. Questions on the last example? All right, cool.